All right, so we're going to start with the simplest form of an interrelated economy, which is called a pure exchange economy. So we're going to forget about production for now and focus on just two consumers and two goods. Each of these consumers is endowed with some quantity of each of these goods. When I mean endowed, what I mean by the word endowed is that they just start with some amount of this good. Okay, and each of them owns some amount of each of the two goods, and we're going to take that as our starting point, and because these are the simplest types of economies in which we can demonstrate the ideas of general equilibrium. Okay, so the question here that we're going to ask is, how are these people going to trade, these two consumers, how are they going to trade with one another? And how much are they going to trade? And what's the final allocation going to be? And finally, is that allocation going to be Pareto efficient? Okay, so to make things a little more concrete, let's call these two people Robinson Crusoe and Friday. And these two guys are stranded on a desert island, and this desert island has only apple trees, which will denote by A, and banana trees, which will denote by B. So we'll call these guys Rob and Friday. Rob's side of the island has 20 apples and 30 bananas. Friday's side of the island has 60 apples and 20 bananas. So those are what I called the endowments. So the endowments are, Rob's endowment is 20 apples and 30 bananas, which will denote by a vector. So the first element is the number of apples, and the second component of this vector is the number of bananas. And this is the same for Friday. That's the number of apples he has, and the number of bananas he has is the second component. Right, so these are the two endowments. So the total resources that are available in the economy are 80 apples and 50 bananas. Right? So there's 20 apples on one side of the island, 60 apples on the other. So altogether there are 80 apples. There's 30 bananas on one side of the island and 20 bananas on the other side. So altogether that makes 50. So what is an allocation? An allocation, or a feasible allocation, is any way of distributing these total resources that are available in this economy between the two. So for example, Rob and Friday could both just keep their endowments. That would be a feasible allocation, right? So Rob consumes his 20 apples and 30 bananas. Rob consumes his 60 apples and 20 bananas. Together, they've consumed 80 apples and 50 bananas, so that's a feasible allocation. But there are lots of other feasible allocations as well. So for example, Rob could consume 10 apples and 10 bananas, and Friday could consume all that remains. So if we give 10 apples and 10 bananas to Rob, then since we have 80 apples and 50 bananas total, there's 70 apples left. And so we give that to Friday, and there's 40 bananas left. We give that to Friday. And so we've got these two bundles. So we call these bundles, by the way. So we've got a bundle of 10-10 for Rob and 70-40 for Friday. Those add up to the total amount of resources that we have in this economy, and so that's a feasible allocation. Now the Edgeworth box is a very nice way to graphically illustrate all the possible allocations in this economy. So let's start with drawing on the horizontal axis the number of apples that Rob consumes, and on the vertical axis the number of bananas that Rob consumes. So remember, a possible bundle that Rob could consume is his endowment, right? He was endowed with 20 apples and 30 bananas. So with these coordinates, we have his endowment as being the one where there's 20 apples and 30 bananas in it. And that's one possible bundle. Another possible bundle might be, let's say, 10 50. So this would be some other bundle. We'll call it X for Rob. So XR would be a bundle where he consumes 50 bananas and 10 apples, for example. Right? So there's lots of different bundles we can represent with these axes. Now we could do the same exact thing for Friday. Again, we put the number of apples he consumes on the horizontal axis, the number of bananas he consumes on the vertical axis. So his endowment, remember, is 60 apples and 20 bananas, so his endowment ends up here given these axes. So the Edgeworth box overlays these two pictures. Right? What we first do is we flip over the picture for Friday. Right? So instead of having the apples, so Rob's apples are increasing in this direction, so we just have Friday's apples increase in this direction. Rob's bananas increase in this direction, we'll just have Friday's bananas increase in this direction. So all we've done is rotate in this direction the picture for Friday, right? Next, what we're going to do is we're going to line up the endowments. Once we do that, we end up with this box, and that box is called the Edgeworth box. Remember, Rob was endowed with 20 apples, and Friday was endowed with 60 apples. So what is the width of this box? The total width of this box is 20 plus 60, so it's 80. So and if you remember, that's the total number of apples we have in this economy. Similarly, Rob was endowed with 30 bananas, and Friday was endowed with 20 bananas. And so when we add those up, we get the height of this box. Right? And again, that's the total number of bananas we had in this economy. What's really nice about this picture is that we can represent every feasible allocation in this box. Right? And this point E represents the endowment. So let's take, for example, this bundle F. Right? I showed you a bundle earlier so I described a bundle for you earlier where Rob consumes 10 apples and 10, let's see. Yeah, so Rob consumes 10 apples and 10 bananas, right? So that's Rob consuming 10 apples and 10 bananas. Right? So from Rob's perspective, this would be the picture. From Friday's perspective, he would be consuming 70 apples and 40 bananas. So this point here describes that other feasible allocation that I described. What this amounts to is Rob gains 10 apples, Rob loses 10 apples, and Friday gains those 10 apples. And Friday also gains 20 bananas, right? He goes from 20 bananas to 40 bananas, whereas Rob loses those 20 bananas. He goes from 30 to 10. So in going from E to F, we took away 10 apples and 20 bananas from Rob and gave them to Friday. Now every such transfer or trade leads us to a different bundle. Right? So every possible feasible allocation is represented in this box. Indeed, anything outside this box is infeasible. Right? So there wouldn't be enough apples and bananas in order to achieve that. Right? So if you want to take a point here from, let's put that in a different color. So take this point here from Rob's perspective, that involves him getting more than 50 bananas. Well, there aren't more than 50 bananas in this economy, so it's just not possible to give that to him. Or take a point here from Friday's perspective, that involves him getting more than 80 apples. There aren't more than 80 apples in this economy, so you can't. That bundle would be infeasible. Right. So let's go back to this endowment, E. We can draw an indifference curve through it. So these would be all the bundles. Right. So in general, we could have drawn an indifference curve for Rob outside the Edgeworth box as well, but the only relevant part is inside the Edgeworth box. So these would be all the allocations that Rob is indifferent between. Right? So any bundle here, Rob is indifferent between that bundle and the endowment. We could do the exact same thing from Friday. Notice that for Friday, we flipped his picture over. So his indifference curves, normally the indifference curves would look something like this. Right? So Friday's picture would look something like this. But then what we did was we took that and we flipped it over. I think we can flip this guy. Or maybe not. Anyway, we took this guy, we took this object here, and we flipped it over, and that's why this indifference curve has this shape. Right? It's bowed towards this origin.